What is Control A.8.11 in ISO 27001-2022? Development teams need realistic data to build and test software. Analytics teams need data to generate insights. But giving these teams access to real personal data, real names, real card numbers, real medical records, creates unacceptable privacy and security risks. Control A.8.11 is a new control in the 2022 revision that requires organizations to use data masking to protect sensitive information while preserving its usability for legitimate purposes. Let us explore what data masking is, how it works, and where it applies. Let us define data masking and understand the different techniques available, from reversible pseudonymization to irreversible anonymization. Data masking replaces sensitive values with realistic but non-sensitive substitutes, allowing data to be used in development, testing, and analytics without exposing the underlying personal or confidential information. Static data masking creates a sanitized copy of a production database that can be safely used in development or testing environments. The masking transformation is applied once during the copy process, producing a dataset where sensitive values such as names, addresses, and card numbers have been replaced with realistic synthetic equivalents. Because the masked data is stored in a separate environment, there is no risk that the masking process can be reversed by someone with access to the non-production system alone. Static masking is the most common approach for test data management and is particularly well suited to regulated industries where any exposure of real personal data in non-production systems creates immediate compliance violations. Dynamic data masking applies masking rules at the database or application layer at query time, without modifying the underlying stored data. When a user queries a dynamically masked system, sensitive fields are replaced in the query results based on the user's role and entitlements. A customer service agent might see only the last 4 digits of a card number, while a fraud analyst sees the full number. This approach is valuable for production environments where different user populations need different levels of data access, but it requires careful design to ensure that privileged users cannot bypass the masking layer through direct database access. Tokenization replaces a sensitive value, such as a payment card number, with a randomly generated token that has no mathematical relationship to the original value. The mapping between the token and the original value is stored in a secure token vault. Applications can use the token to process transactions without ever handling the underlying card number, significantly reducing the scope of PCI DSS compliance requirements. Tokenization is reversible for authorized systems with access to the token vault, making it suitable for use cases that require occasional access to the original value, such as fraud investigation. Pseudonymization replaces directly identifying information, names, national insurance numbers, email addresses, with artificial identifiers. The mapping between the original identifier and the pseudonym is held separately, allowing re-identification when authorized. GDPR explicitly recognizes pseudonymization as a risk reduction technique. Pseudonymized data is still personal data under the regulation, but its use attracts reduced regulatory scrutiny and may enable lawful processing for research and analytics purposes that would otherwise not be permissible with fully identified data. 4 key concepts that distinguish different approaches to data masking and their relationship to data protection law. Anonymization is the gold standard of data masking because it removes data from the scope of data protection law entirely. If data has been genuinely anonymized, meaning that re-identification is not reasonably possible even using external datasets or sophisticated techniques, it is no longer personal data under GDPR and can be used, shared, and retained without the restrictions that apply to personal data. However, true anonymization is technically difficult to achieve and must be validated rigorously. Many datasets believed to be anonymized have been re-identified in research studies, so organizations should seek specialist expertise before relying on anonymization as a legal basis for unrestricted data use. Test data management is one of the most common and practically important use cases for data masking. Development and testing environments typically have weaker security controls than production systems, are accessed by a wider range of personnel, including contractors, and may be shared with third-party vendors for software development. Using real personal data in these environments creates material privacy risk and typically violates GDPR requirements. A structured test data management program using masked or synthetic data eliminates this risk while still providing developers with the realistic data distributions and edge cases they need for effective testing. The reversibility of a masking technique determines its data protection impact and the legal framework within which the masked data sits. Pseudonymization and tokenization are reversible. The original value can be recovered by an authorized party with access to the key or token vault. Anonymization is irreversible. Once applied correctly, the original value cannot be recovered. This distinction matters significantly for GDPR compliance. Pseudonymized data remains personal data and must be handled accordingly, while genuinely anonymized data can be treated as non-personal data. Organizations must understand the reversibility of each masking technique they deploy and apply the appropriate legal framework. Control A.8.11 sits at the intersection of information security and data protection. By requiring data masking, ISO 27001 is reinforcing the GDPR principles of data minimization, using only the data that is necessary for the purpose, and purpose limitation, not using data for purposes other than those for which it was collected. Organizations that implement A.8.11 effectively are simultaneously strengthening their GDPR compliance posture, reducing the risk of data breaches involving personal data, and demonstrating to regulators that they have embedded privacy by design thinking into their data handling practices. Let us now look at where data masking is applied in practice and what organizations need to consider when selecting and implementing masking techniques. Data masking is applied wherever sensitive data must be used outside its original, secured context, in development environments, analytics pipelines, shared datasets, and third-party integrations. Development and testing is the most urgent and widespread use case for data masking. Organizations that routinely copy production databases into development environments, a common practice in organizations without a structured test data management program, are exposing personal data to a significantly larger population of personnel and systems than those covered by their production access controls. Implementing static data masking to create sanitized development datasets is one of the highest impact steps an organization can take to reduce privacy risk and demonstrate GDPR compliance, and it is frequently identified as a finding in both ISO 27001 and GDPR audits. Analytics and business intelligence workloads often require access to large volumes of data that include personal information. Where the analytical purpose can be achieved using aggregated, pseudonymized, or anonymized data, organizations should implement masking to avoid processing personal data unnecessarily. Masked analytics datasets reduce the regulatory risk of the analytics function, make it easier to share data with business intelligence partners, and reduce the damage scope if the analytics environment is breached. The key technical challenge is ensuring that the masking does not distort the statistical properties of the data in ways that compromise the validity of the analytical outputs. Sharing datasets with third parties, technology partners, research organizations, auditors, or outsourced service providers creates data protection obligations that organizations often struggle to manage effectively. Data masking provides a practical mechanism for sharing the information that partners legitimately need while withholding the sensitive fields they do not need. Before sharing any dataset externally, organizations should apply masking to remove or replace personal and confidential fields, document the masking approach, and confirm that the residual dataset does not permit re-identification through combination with other available data. GDPR compliance directly motivates much of the investment in data masking. By applying masking to reduce the volume of identifiable personal data in non-production and analytics systems, organizations reduce the scope of their GDPR obligations, lower the potential impact of data breaches, and demonstrate to supervisory authorities that they have taken the data minimization principle seriously. Data masking is increasingly referenced in regulatory guidance as a concrete technical measure that organizations should implement, making A.8.11 not just an ISO 27001 control, but a practical GDPR compliance tool. Let us consolidate the essential points from our exploration of Control A.8.11 data masking. If you want to master all 93 Annex A controls in ISO 27001-2022, our complete Udemy course covers every control in depth with practical implementation guidance, policy templates, and audit-ready evidence frameworks. Enroll today and build the security knowledge your organization needs. Thank you for watching. If you found this helpful, please like and subscribe. See you in the next video.